we're given a really messed up equation. 4x squared plus 16x plus y squared minus 6y equals negative 21. We're asked to find the sketch and the foci. Now, we know the standard sketch. Now, we're working with ellipse, right, in this section, so let's just assume that this is an ellipse. We're going to learn later how to identify quickly whether it's an ellipse or a different type of conic section. To get this written in our standard form, let's remember what the standard form looks like before we work with this. Well, we've got 4x squared plus 16x. Let's gather those together. And then plus, let's gather the y's together. Y squared minus 6y equals the other side, negative 21. Okay, so the standard form that we're going for, I'll draw it here on the side. It's the x minus h parentheses squared over the a squared plus y minus k parentheses squared over the b squared equals 1. That's where we want to end up after we complete the square. Okay, so we've gathered the x's, we've gathered the y's, and they brought down the equal sign and the number on the other side. Now we're going to factor out the coefficient of the squared guys. Right, so this is going to be 4 times x squared plus 4x. You have to factor it out of both, not just the first term. This one's just the invisible y, so there's nothing to factor. I mean, the invisible 1 is the coefficient in front of the squared y squared, so there's nothing to factor out. Okay, next we are going to complete the square inside of each of the parentheses. So we have x squared plus 4x, okay, here we go, plus bracket 1/2 times the coefficient of x, which was positive 4, close your bracket, square it, and then subtract the same. Well, instead of subtracting the same thing, we will subtract it from the other side of the equal sign. Okay? All right. Plus, bring down the y squared minus the 6y plus bracket 1/2 times the coefficient of y, which was negative 6, close your parenthesis, close your bracket, square it, close your parenthesis, equals, okay, now be careful. You bring down the negative 21 on the other side, but then you want to do the same thing on this side of the equal sign that you did on the other side of the equal sign. What did you do? Well, it looks like you added 1/2 times 4 bracket squared, but you really added 4 times that amount because that 4 on the outside actually multiplies each of the terms inside the parenthesis. So when you add the same thing on this side, you're actually adding 4 times bracket 1/2 times 4 parenthesis bracket squared. Now we've done the same thing on both sides. Now also, don't forget the other guy that you add, half negative 6 bracket squared. You added that on the left side, but there was no number outside of the parenthesis, so you're simply going to add the exact bracket 1/2 times negative 6 parenthesis bracket squared. On the next line, you're going to simplify inside the bracket only. I'm going to leave a little space. It's getting crowded here. So we have the 4 that was left behind, x squared plus 4x plus, simplify inside the bracket, half of positive 4 is 2, bracket squared, close your parenthesis, plus parenthesis y squared minus 6y plus bracket half of negative 6 is negative 3, bracket squared, close your parenthesis, equals negative 21 plus 4 times bracket positive 2 squared plus bracket negative 3 bracket squared. Okay, so we just simplified. That's all we did was simplify inside the parenthesis. Now we're ready to factor this material here using the formula is 4 times x plus the stuff in the bracket including the sign and then the square on the outside plus parenthesis y plus the stuff in the bracket including the sign and the square on the outside equals negative 21. Let's see, let's simplify this. 2 to the second power is 4. 4 times 4 is 16 plus 16, negative 3 squared is positive 9. Okay, so let's one more time simplify. 4 times x plus 2 parenthesis squared plus y minus 3 parenthesis squared equals, let's see, negative 21 plus 16 plus 9, so that's like negative 21 plus 25 gives me 4. All right, now we need to get rid of any of the coefficients outside of the parenthesis by dividing both sides by that. And we just have a 4 out here, so we're going to divide everything on this side by 4 and everything on the other side by 4. These cancel. So I got x plus 2 squared plus y minus 3 squared over 4 equals 1. It's looking great. The only thing is I don't know what's on the bottom of x plus 2 squared. Well, we're going to write it really carefully to look like this. It's going to be x minus a negative 2, outer parenthesis squared, over, well, what's down below? There's 1, and 1 is the same as 1 squared, plus y minus 3 parentheses squared over, let's see, write 4 as 2 squared equals 1. Okay, put a box around that. That is your equation of your ellipse. And now that we've got that equation, we can do the sketch. Now, they didn't ask for the equation. I'm making a big production out of it and putting a box around it because it's so important to answering the question. Because what does this tell us? It tells us that the h is equal to -2. The k is equal to +3. The a is equal to 1. And the b is equal to 2. And that information is going to help us do the graph. Now, what else do we do here? Let's see. Let's go ahead and start our picture. Okay, so I started my axis y and x, and I've located the ordered pair with the value -2 on the x-axis and 3 on the y-axis because I know my hk is located at -2, 3. Let's go ahead and locate that here. There's my center, hk. Now, the a distance is 1 unit. That means I'm moving left and right from the center, hk, from the center. I'll go ahead and write this. This is -2, 3. So I'm going to move right or left 1 unit. So that takes me here, and on the other side it takes me here. Okay, those are points on the right and left side of the center that are going to be on the ellipse. Now let's go up and down. What is the b value? Up and down, it's 2 units. So let's go up 1, 2 units up to here from the center, and down 1, 2 units down to here from the center. And we can actually start the picture coming down like this, then around like this. Okay, that's a rough drawing of our ellipse centered at -2, 3. And you can see we've got all the distances accounted for, but what we don't know is the location of the vertex yet. So let's just do a dotted line here. This is our b distance, and that is our a distance. All right, so what I want to recognize is that this has got to be the vertex, v sub 1, and this has to be the other vertex, v sub 2. The major axis is clearly the vertical axis because it's longer than it's wide. Also, we know the foci are going to live somewhere inside. Okay, so this is going to be f sub 1, and f sub 2 will be somewhere down here. F sub 2. Now, let's form our little right triangle in here, an embedded right triangle, and let's bring it out to do an analysis of the lengths of each of the sides. Pythagoras, which says hypotenuse squared equals leg squared plus leg squared, and we'll solve for the c value. So hypotenuse is 2. 2 squared equals leg squared. One of the legs is a, it's equal to 1 squared, plus the other leg squared, c squared. So the hypotenuse is the edge across from the right angle, it's 2. So it's hypotenuse squared equals leg squared plus leg squared. Let's solve this for c. 4 equals 1. You're going to be moving up and down without getting a negative distance. So, because we're not at the center anymore, we're not located at the origin. So you want to keep both the plus and the minus. Okay, so look at the picture there. If we know that this distance is c, plus or minus the square root of 3, that means we're going to go up. Well, I suppose it would be okay just to call it take out the minus, just keep it positive for now. Just keep it positive square root of 3 because that's just the distance. It's the distance equals the square root of 3. Okay, so that's what we found. And if you put the square root of 3. So that is the second part they wanted me to find, the location of the foci. I can write it all together as f equals -2 for the x-coordinate, and then 3 plus or minus the square root of 3. That's both of them written together in one expression. And we're done.